In this video, we will see a piece of Python code that can help us to slice a long piece of data into segments and having each segment plotted individually and stored in a folder. Also, we will plot the long piece of data in colored segments so that it's easier to look at. Here is the code itself is not very long. It's actually very concise and well structured. Here we need to import some library in advance. The library include NumPy, include pandas, include matplot library, plot, include OS, include Shuttle. This OS and Shuttle is mostly for the short piece of data that help to organize the files into folders separately. This is explained in last video. If you are interested, you can refer to that. And here we come on starting from 27, this line, we come to the data folder. Next, we come to the data name. The reason that the data name is very, very obvious, you can just copy the short piece of txt into the data name and then put in a single quote, then it will work. But here I use this list directory to have the data name saved in a list instead of just a piece of text. Is to let's say, in case that you have more than one data and you want to scan to operate on each data automatically in the future, so I use this indirect reference, but just put in the piece of text will work. And next, it's data itself. We use NumPy loadtxt to load this data. So the parameters is very straightforward. So the first parameter, you can just put the path of the data. Getting the path of data, it's very easy. Copy as path, and we can put it here, paste. And you can see this is a little bit long, and this slash is pointing to the right. We need to get all the slash pointed to the left. So in order to have the code look conciser, I used a little bit small trick. Let's see. The trick is to concatenate the folder path with the name of the file. That's it. And then it's becoming that short. The name of the file is stored in the list that we just created, the data name. The type of data name, like let's say this is a list, and the list contains many elements. In our case, there's only one element, and the first element. Anyway, and then the next is we tell the code, tell the computer the delimiter of the file. Yes. Since I know that this is the file, the data, since I know the delimiter is a comma, so I put a comma here. Sometimes it's just a space. You know, if it's a space, then you don't. I think maybe. Anyway, but we can skip that. If it's a space, we can delete this parameter. I think so. Maybe, or we need to specify a space here. Let's skip this in this video. So next, we create a font library. Why do we do this? This is to save space later on. Let's say because later on we need to plot each segment of data, and in the plot we want to specify the font name, the font color, weight and size, things like that. Instead of having all the parameters listed in a long line, later we create a library here just as font, so later we can point reference to these font. That will be a little bit easier. Okay, next. Okay, so creating a library, we need to follow the syntax of the Python. As you can see, this is how the syntax should. This is single quote and then comma, and then this is user defined. You can define whatever you want. Next, we make a data structure, which means, so here you can see this is slice. Each color is a segment of data. Slice size, this is the 1 million, which means in each segment there are 1 million points. Obviously, we cannot see 1 million points in the short segment because they are all jammed and they become so thick. But I can show you in MATLAB. MATLAB is very, let's say, I like MATLAB, and it can help you to zoom in data points very well. Okay, so this is how, if we zoom in so many data. Okay, still jammed, and we zoom in and still jammed. Now you can see a lot of points, and okay, and they are jammed together here. So one color contains 1 million. And next, we want to get the number of slice. Here, 1, 2, 3, 4, 5 slice. So the number of slice can be get through the single operation. We got the length of the whole data, the full range, full size, let's say the length of the how many data in total, and divide by the slice size. And this is not single slash, this is to divide into integer multiple, and we cut off the remainder, so the tail will be ignored in this case. And next, we give the full data a variable name. So, and since I know that there is a current and there is a time here, this is a full range of the current and time we want to plot. By full range, we mean the integer multiple of each segment. Here you can, we can see from the MATLAB. The MATLAB is just for demonstration. In next video, I will explain how to do the similar job using MATLAB. Both MATLAB and Python, they have their own advantages that you can choose whichever you want to use. So here, the full range is an integer multiple of the slice size. As you can see here, I will brush and show you. Here is the tail, and tail is ignored here in this video. Okay, we see tail is ignored, and you can see here, no tail. Tail is truncated. Okay, so this is to get, you can see this is the index, the column index 2, which means the third column in the txt file. And this is the first column of the txt file. It just indexed from 0. Many languages do that. They do this and it's useful. And next, we split the original data into pieces, and we want to save separate files. This is a short piece of data, a short piece of code. So we use a for loop, and the loop iteration number, obviously you can imagine it will be 5. So there are 5 segments of data. So from 0 to the slice count, here the slice counts will be calculated as 5, and from 0 to 5, it will stop at 4. This is how it works. And next, we make a variable data split 2 dimension. So this is from I times slice size to I plus 1 times slice size, which means it's 1 segment of data. And next, we make a variable, this is segment. We use pandas DataFrame function. DataFrame can, what does this function do? DataFrame can get, it's like a box, meshed box, a 2D, let's say, in our case 2D, and then we can have all the data project on the data frame. I will put the pandas data frame link below, so we can or you can study the specific details. Next, we get the data to CSV, so we use toCSV function to have all the data dumped into a CSV file, then to save for us. Here there's a parameter. You can just get the data folder here, concatenate with the name of the file you want to make. This is user defined. This is very helpful, very convenient, I found. So the name, you can define this and then add a string I plus 1. So this will automatically generate a number for you. So segment 1, segment 2, and header none, index none. Header and index is like an Excel file. If you can recall, you have header, you have index. To have header none and index false, that means we do not put header and index there. And next, we plot our figure by using plot.figure function. And the first parameter, you can put here the name, also concatenate with the number of segments, and we specify the resolution to be 200. And next, we use plot function to plot the column. So the first piece should be x-axis, and this is y-axis. So data. So what is this x-axis? We can look into it. So this is the data. You can see here data, and this will reference to this data because we named this data here. And so the full range of data, we segment each data. So the slice size, so starting from 0, I start from 0, then the first slice size, and slice size. I don't know how to explain this, but I think you understand. And this is the first column of the data is like the first column. We took the first column of the data all the way from the first one to 1 million. That is how it means. And this is the third column, which index as 2. So this will take all data from the first one to 1 million and have it plot. So on the data, on the figure, we plot it. We put X label here, and we put Y label here, and we put title here. X label, now we see the convenience that we created just now as the font library. So we use font diction, this variable, and we reference to this font. Then all these parameters in the font library will applied to our figure. Instead of having all of these paste here, making this line of code super long, this looks much concise. And the last line, we save this figure. So we put the data folder here as the path where the figure can be stored and concatenate with the name. Here is automatic segment generation. And let's see how it works. We will run this piece of code, run this piece, and we look at the right folder. Segment 1 generated, segment 1 generated plot, segment 2, segment 3, segment 3, 4, 4, okay, 5. 5 comes out. We look at this. So this is the first segment. We can compile this. This is the full range. This is the first segment, and this is the first segment. 1 million data here in each segment. Okay. Next, we also want to plot the full range of data. It is a similar operation. So everything here are similar, except that we have the segment T. We have this variable segment T and segment I. Segment T is let's say it's segment T. Yeah. So segment T comes from this data segment T comes from the data T4 here, and we just give the index of where we want to plot. And this is segment I, and now we plot. We use plot function. This is X. This is Y. So this is the first column of the data. This is the third column of the data. This is user defined. You need to know where your data locates, since I know that my data locates on the third column. Index as 2. And the first column index as 0. And this is an integer, like you how to say, I don't know how to explain, but it is integer multiple of the slice size 1 million. So we plot every 1 million data, and we put X, Y, title, and we save figure the same way we save figure in the last segment of code. And let's see, we run this. And see how it's already here. So this is a full plot and it's in color. Thank you very much. I hope this is useful for you.